a very good Saturday to you. It's Jonathan Harris here, and it's partly cloudy in London, as I imagine it is in many other places too. This week, as we sift through the usual torrent of pronouncements, I find myself returning to Alan Turing's rather optimistic observation that, and I quote, "Those who can imagine anything, can create the impossible." A fine sentiment, certainly. But as we know, imagining and doing are often separated by a rather substantial gulf. And it's that gulf, that space between the bold claim and the tangible result, that we'll be examining today. Because in this field, as in so many others, separating the genuine signal from the rather insistent noise remains the perennial challenge. This is Turing's Torch, Artificial Intelligence Weekly, the bits that matter, minus the hype. People often talk about artificial intelligence like it's either a miraculous new lens or a cunning new weapon. The truer line is flatter and messier. We've built tools that see and act in ways we could not before. And now we are discovering how little of the world those tools actually understand when the weather changes. The power blinks, or the incentives do something awkward. That understatement is the theme for the week, and the practical question is less about whether the models are clever, and more about how they behave when they leave the lab and meet the real, inconvenient world. Take conservation. There is a neat, hopeful picture: camera traps and microphones that never sleep, satellites that flag habitat loss, machine learning that identifies species without a biologist standing in the rain. The reality is harder. Field photographs are overexposed, microphones pick up tractors and wind, and rare animals appear. So seldom that models have only handfuls of examples to learn from. Deployments force trade-offs. Run everything in the cloud and you need constant power and connectivity, run it at the edge. And you squeeze models into tiny batteries and even tinier CPUs. Good systems end up hybrid machines that triage and humans who verify rather than miracles that replace expertise. That matters because monitoring data directly shapes conservation decisions. If a system says a species is declining, managers reallocate finite patrols and funds. Misclassification wastes scarce time, missed threats leave species exposed. There are also governance problems when commercial vendors supply turnkey sensing with opaque models. Dependence on systems you cannot interrogate hands money and control to suppliers rather than to local communities and reserve managers. Useful progress, then, looks prosaic, small, well-validated systems, honest reporting of failures, contracts that pay for long-term maintenance, not just pilots. Close to the natural world are other places where seeing and acting intersect. In retail, carts that recognize what you put inside them are no longer futurist fantasy. A handful of stores are testing smart trolleys with cameras, scales and indoor location systems. The pitch is convenience. Pop items in, the cart knows your loyalty status. It serves coupons just as you ponder a choice and, potentially, pays without queuing. The trade-offs are obvious. Those carts are powerful nudging devices. They know where you linger and what you pick, and that data is valuable for targeted promotions. For a mid-sized grocer, smarter carts promise higher basket sizes and fewer tills, which explains the commercial hunger. For customers, they reconfigure privacy and consent. Who owns the footage and purchase history? How long is it kept? Can it be used to profile people or sold to advertisers? Convenience will win many bets, but the quiet question is whether shoppers consent with full understanding or effectively accept profiling because the checkout is faster. Commerce and convenience also meet at checkout in other, more delicate ways. Payment rails have quietly been wired into conversational agents. Some platforms now let an assistant not only recommend an item but finish the transaction, browse a catalog, pick a product, then trigger a card payment on your behalf. That is a small step for the interface and a big leap for responsibility. A human used to have a final click, a last look. When that checkpoint disappears, you shift who takes liability for mistakes. Did the agent misinterpret a prompt and subscribe you to a recurring service? Did it buy the wrong item at full price? When fraud happens, determining whether the user, the merchant, the payment network or the platform is on the hook becomes a legal puzzle. Payments companies profit from volume. Platforms that control both recommendation and settlement get the dual benefit of influence and the fees. That's powerful and worth regulatory attention. If handing your wallet to your assistant sounds appealing, insist on revocable consent, robust authentication, and explicit rules about liability. Expect some awkward bank statements to force public debate. And where money moves, so does risk. Insurance firms are swapping stacks of paperwork for algorithms that hunt fraud at scale. One insurer reported uncovering several £100 million worth of sophisticated fraud, and is now using machine learning to detect coordinated schemes across claims, payments and medical notes. The systems are good at pattern matching and linking disparate claims faster than human investigators can. The important caveat is that algorithms bring their own errors. False positives turn customers into adversaries and create reputational risk. The right test is not how many flags a model raises but whether it materially reduces successful fraud without harming legitimate claimants. Procurement that buys a model and assumes the problem solved will discover that detectors need tuning, human oversight, and audits the same dull work we keep rediscovering in every sector. Security, incident response and the notion of autonomy come into focus when agents are allowed to act without a named person looking over their shoulder. Autonomous pen testing platforms are one example. They try to codify what a human red teamer does, map attack routes, check whether vulnerabilities can actually be chained into a foothold, and produce proof of concept exploits. For defenders, the appeal is clear. Security teams drown in alerts and have limited budgets. Vendors promise to prioritize real exploitability over raw severity metrics, which helps boards and compliance officers who want demonstrable risk reduction. But the optimistic picture glosses real trade-offs. Automated exploit attempts against live systems risk causing outages. Models infer likely attack steps, they do not prove adversaries think the same way. And there is a legal and ethical question: who is responsible when an automated agent launches an attack, even in the name of testing? The sensible posture is augmentation rather than replacement. Run such tools in controlled environments first, require manual sign-off for live exploits, keep thorough logs, and treat autonomous as a product label, not a license to be careless. Those same problems scale across many autopilot claims. Organizations are increasingly handing agents authorization to act across apps and infrastructure to run builds, push config changes, or rotate credentials. When an agent holds a service account or an API key, it can do in seconds what used to take multiple human approvals. That's efficient, but it shortens the window to stop a cascade when something goes wrong. A misapplied glob or a misplaced path can delete data at machine speed. The defensive playbook is, frankly, old engineering, least privilege, short-lived credentials, human approvals for destructive actions, canary deployments, and rapid rollback scripts. Those measures are boring and work. The modern mistake is to treat them as optional because an artificial intelligence seems smart enough. It is not. If you give an agent the keys, design the locks first. The shortcuts that make agents powerful also invite new forms of trouble: customer touchpoints. An automated customer support system was recently used to relink account recovery channels to addresses controlled by an attacker. The change made control of an account trivial to claim. The novelty was not clever hacking, it was the reliance on an obliging automated interface that complied with a plausible request without enough friction for high-risk actions. Bots are cheap and fast to probe. Humans, slow and inconsistent, used to provide friction. Automated systems provide uniform behavior, which attackers can exploit with automation of their own. The countermeasures are pedestrian, human review for high-value accounts, stricter authentication for recovery flows, anomaly detection tuned for automated probing, and audit trails designed to be interrogated after incidents. If you design a system to be helpful above all, do not be surprised when helpfulness becomes gullibility. Model releases and the business choices that surround them deserve scrutiny too. Some companies have moved capabilities that were previously in restricted previews into public product lines. Sometimes packaged as two variants of the same core model with different safety guardrails. On paper, that's sensible, one setting for broader use and another for heavier-duty research under tighter controls. In practice, it concentrates a tough choice into product tiers. If safety becomes a premium feature, the incentives shift predictably. Customers who pay more can access more capability and, perhaps, fewer constraints. That arrangement accelerates innovation for some and increases systemic risk for others. Independent, reproducible evaluations are scarce when capability is iterated privately. Releasing models publicly does not make them safe, it makes them someone else's problem. Demand audit reports, insist on third-party testing, and treat vendor claims as marketing until validated. Parallel to questions about who gets what capability is the deepening conversation about provenance and dependencies. Apple's new assistant, which leans on a major search provider for web answers, is a case in point. User interface and brand do not erase the plumbing. When an assistant sources current facts from a third party, that third party's ranking choices shape the answers millions of users will get. That is influence, and it interacts with antitrust concerns and privacy trade-offs. Outsourcing the web layer changes how query metadata flows and who sees it. Speed and convenience are seductive, but they can mask dependencies that concentrate control and create regulatory headaches. We see the same pattern in developer tooling. Access to models is no longer the boundary, the problem has shifted to choice and integration. The market is full of orchestration platforms, prompt managers, vector stores, observability tools, automated labeling systems and more. Each is sold as the thing that will save time, but each also adds another tab to the day and another vendor to manage. The cognitive overhead of learning and integrating several specialized tools often dwarfs the productivity gains. Teams end up with vendor lock-in, brittle integrations and a bigger operations bill. The sensible approach is to treat tooling adoption like a product decision, short trials, clear exit criteria, and honest accounting for the integration cost. That operational realism extends to the modest arts of production. A very plain playbook for moving artificial intelligence from demo to production has become popular for good reason. A prototype shows what is possible in ideal conditions. Production asks different questions. How do you handle malformed inputs? What happens when traffic spikes? How will you detect model drift? Practical measures, scope cuts, stable prompts, reliable data pipelines, monitoring, rollout controls, and an actual changelog matter more than the latest model checkpoint. If you cannot point to a changelog and a monitoring dashboard at audit time, you have nothing to show. Reliability is operational, not magical. Prompt engineering has begun to be industrialized. Tools that automatically optimize prompts by running many rollouts, scoring, reflecting and updating are now part of some teams' toolkits. They reduce manual fiddling, and can yield measurable gains without changing model weights. That is useful but not costless. Automated optimization consumes tokens and compute, centralizes control over what behavior is rewarded, and can optimize for the wrong metric if your validation is weak. If you automate prompt tuning, instrument everything, tokens used, changes made, model versions involved, and a held-out validation set that checks for overfitting. Metrics without governance are merely expensive opinions. The same theme applies to retrieval and search. Retrieval is the plumbing behind any system that claims to answer questions with evidence. New work on dedicated retrieval subagents, trained with reinforcement learning to fetch, check and curate sources, shows that modularizing retrieval can materially improve what a generator has to work with. Public weights for such subagents are a welcome step for reproducibility. But retrieval tuned for recall may be less cautious about borderline sources. And a powerful retriever is still only as useful as the policies that decide which documents are admissible evidence. Modularity helps inspectability, but it also requires rigor about provenance, source quality and the cost of running larger subagents in production. Choosing the storage for those retrieved fingerprints is another consequential decision. Vector databases are the unsung, technical choice that determines latency, cost and accuracy of semantic search. They are not glamorous, but they decide whether a delightful demo survives scale or becomes an outrageously expensive prototype. Benchmarks are helpful, but only real workloads expose the trade-offs: latency under realistic concurrency, recall for your query mix, resilience during reindexing, and the cost of integrations. Pick a vector store to match your data, your team's skills and your tolerance for operational complexity, not because it looks good on a vendor chart. There are also fresh model architectures pushing at cost and speed. Some teams are experimenting with coupling mixture of expert scaling and diffusion style generation for text, a combination that claims significant speedups on GPUs for some workloads. Others are shipping small, efficient multilingual speech models designed for real-time streaming across many language locales. And companies have released multimodal models offering very large context windows, hundreds of thousands of tokens pitched as laptop-friendly. Those are interesting technical directions. Faster generation and longer memory change product economics and user experience. But they do not erase the costs of integration. More models demand custom kernels and careful load balancing. Diffusion for text brings numerical tricks that complicate deployment. Large context windows are powerful, but local use still depends on hardware and compilation choices. Open releases democratize capability and scrutiny, but they also lower the barrier to misuse. Every engineering gain shifts the trade-offs rather than magically solving them. Practical, safety-oriented toolkits are emerging alongside these architectures. Firms are publishing red teaming workflows that automate systematic probes, bundle findings and export them in a structured way. That kind of tooling is useful because it turns ad hoc testing into a repeatable, auditable process. It raises the baseline for defenders and regulators. But a tutorial is not a cure. Probes cover scenarios you think of, attackers look for blind spots you did not. Detectors generate both false positives and false negatives, and structured exports help remediation only if somebody is assigned to act on them. All this engineering and tooling matters, because agents are getting longer strides. People are building long-running agents designed to manage tasks that extend over hours, days or weeks. The technical solution is pedestrian, external memory stores, checkpoints, summarization and an idempotent step design. The painful part is the plumbing. What to persist, how to structure it so reloaded state makes sense, and how to avoid duplicating work when retries happen. Those decisions push complexity into orchestration, observability and human oversight. A long-running agent is useful only if you can explain why it did what it did. Provenance, audit trails and human fallbacks must be first-class, not afterthoughts. Those requirements are not abstract governance exercises. They reshape labor and leadership. When agents proliferate, management is less about coordinating people and more about setting goals for probabilistic systems and understanding confidence scores. That demands a new set of roles: agent operators, prompt designers, compliance translators and different budgets. Buyouts and prototypes will not suffice. Workshops that produce enthusiasm without concrete decisions are a waste. If an artificial intelligence strategy session does not leave the room with a named owner, measurable pilot criteria, and decision gates, it has been theater, not governance. Run the workshop like a factory for choices, not like a showroom. Well, that was rather a lot to get through, wasn't it? In times like these, when the digital ether hums with pronouncements both grand and, frankly, rather dubious, a bit of clarity is, I find, a welcome commodity. If you'd like a daily digest of this unfolding story, delivered straight to your inbox, just one email. Mind you, no unnecessary fanfare. You can find that at jonathanharris.online. And for those of you who've been asking about further reading, my own modest contribution to the discourse. Artificial Intelligence for Wildlife Conservation, Changing Biodiversity Protection Through Technology, is available in the ebooks section of the site. That's your lot for this week's Turing's Torch. If you want the daily brief, head to jonathanharris.online. Same time next week. Try not to believe the press releases.